Now the important most application of dimensions we are dealing with, that is the third use of dimensions or dimensional analysis. What is that one? We can derive equations taking the relationship between the physical quantities using dimensional analysis. So, what is the third use over here? That is to derive physical equations. To derive physical equations taking the relation between the quantities. Between the quantities. Now, this derivation of course we can make it by considering dimensional analysis. That is the point what we have to understand out of it. So, whenever they come across derivation or the relationship between the physical quantities when we want to derive using dimensional analysis, what is the method they adopt generally? The question will be given, say for example, this way: pressure due to a liquid column, pressure due to a liquid column, I take it as P. It depends on the very first one, height of the column, whichever liquid we are considering, its height, that of course we can take it as h. The second one here is density of the liquid, density of the liquid, that of course rho we can take up. And coming to the third one, that is acceleration due to gravity, acceleration due to gravity, that is what we take it as G, small letter. So, suppose the question is given this way: pressure due to a liquid column P depends on height of the liquid column, density of the liquid, and acceleration due to gravity at that particular place. Then what is the question asked? What is the relation between pressure, height, density and acceleration? In other words, I may ask you like this also: derive an expression for pressure dimensionally, taking this concept into account. Derive an expression for pressure due to the liquid column using dimensional method or using dimensional analysis. That is what actually the question. But in all these models, the methodology remains the same. See the method first. We have been given in the problem that pressure is depending on three quantities. What are those three? Very first one is height. Second one is density. Third one is acceleration due to gravity. But pressure is depending on height is the statement mentioned. Depending means it may be directly proportional to h, may be inversely proportional to h, may be directly proportional to square root of h, or may be directly proportional to h cube or h to the power 4 or h to the power 1 by 4 or anything like that. But what exactly is the relation, we do not know. It simply depends on it, that is the statement mentioned. Therefore, what we used to do here, we take P is proportional to h to the power x. To which power it is proportional we do not know. Therefore, I take the power of h as x, power of rho as y and power of g as z. If I can estimate the values of x, y and z using dimensional methods, I directly can substitute those three values here to conclude the relation between pressure, height, density and acceleration due to gravity. So, that is the methodology what we just have to adopt. So, let us say height has got a power of x, rho has got a power of y, g has got a power as z. I just want to calculate these three values right now. So, what is to be done? You take P is equal to first a constant k into h to the power x, rho power y, z power z you write first. What is that k? Every one of us can directly understand it is constant of proportionality. In fact, one should understand constants of proportionality values one cannot directly calculate using dimensional methods. That anyhow we are going to discuss a little later while discussing about what are the limitations of dimensional analysis. So, when you talk about h power x, rho power y, g power z, just take the dimensional formulae of all the known quantities out of the equation. Why should we write? When this is the equation which is true in my opinion, dimensionally also that equation is supposed to be correct. That means LHS and RHS, while when we write dimensional formulae, they are supposed to be equal. So, if I take here, we will be getting m, L inverse T power minus 2. That is the dimensional formula for pressure which one need to remember directly. Now, you can say here h is L to the power x, rho is m L power minus 3 to the power y, g L T power minus 2 to the power z. So, I have written the dimensional formulae of all the physical quantities what we are having in this equation. Now, you write, take the right hand side values, you write all m terms together, all L terms together and even T terms together. Then what can you write now? M to the power y here, only one term of m we have, L to the power x minus 3y plus z, and there is only one term of t we have, that is t power minus 2z, that is equal to what? M power 1, L power minus 1, t to the power minus 2, that is towards your left. So, what you need to do in this case is a very simple thing now. Equate the powers of mass, equate the powers of length, equate the powers of time. What is it you are going to get? You just check. Suppose if you equate the powers of mass, you will be left with y is equal to 1. When you just compare, if you equate the powers of time, you will be getting z as 1. Substituting those two values and equating, while equating the powers of length, you again will get the value of y also as 1. So, what we can understand out of that one? X will be 1, y will be 1 and z also will be 1. These are the three values what we are going to get after simplification or after equating the powers of mass, length and time. The moment we have got these three values, what is going to be the equation for pressure now? Pressure now can be written as k times h to the power 1, rho to the power 1, g to the power 1. This is the relation between pressure, height of the liquid column, rho the density of the liquid, and g is acceleration due to gravity. But one should understand here this value of k, which we call it as the value of constant of proportionality, that cannot be worked out using dimensional methods. So, one cannot directly calculate the value of k, but since we have here proportionality sign which is converted into equality sign, therefore, we need to consider the value of k. But okay, we all in fact know well k value in this equation is going to be 1, because we are all aware of this equation. Pressure due to any liquid column is h rho g, that is actual formula. H is height of the liquid column, rho the density of the liquid taken up, and g is acceleration due to gravity. So, if you take and accept this equation, it is very clear to say that the value of k as 1, but k value which I am considering here as 1 cannot be obtained dimensionally. I am repeating once again. Means what? Dimensional analysis is not going to give us the values of constants of proportionality. That is a point what you have to remember from this entire description. So, by just taking the relation between the physical quantities mentioned in the problem, one can directly arrive at that particular relation between those quantities using dimensional methods. That is actually the third use of dimensions. Let us take one or two more examples in this regard, so that every one of you can understand how to just calculate the powers, which of course here are taken as x, y and z. Let us consider one more example taking the same third use of dimensions. It is given that V is directly proportional to m to the power x, g to the power y, r to the power z. There is an equation given this way, and it has been mentioned that V is velocity, m is mass of earth, and g is gravitational constant, that is also called universal gravitational constant, and r is radius of earth. And V in fact has been given this way as escape velocity. Direct formula is known to all of us. Escape velocity is under root 2 gm by r. But of course, let us start this way that we do not know the basic equation of it. This is the equation mentioned. Now, I just need to tell what are the values of x, y and z. Find the values of x, y and z will be the question. So, what is to be done first? Take the dimensional formula of V. It is m0 L T inverse, that is equal to m to the power x, g m inverse L cube t power minus 2 to the power y, and r is nothing other than length to the power z. So, this is for mass, gravitational constant and radius. Let us write all m terms together again. M to the power x minus y, L to the power 3y plus z, t to the power minus 2y. That now is going to be m power 0, L to the power 1, t inverse. That is actually the concept. Now, let us first of all equate the powers of time, so that we will be getting one value, that is y. So, you can write minus 2y is equal to minus 1, then y becomes half. Now, let us equate the powers of m this time. X minus y is equal to 0, that implies x is equal to y, that implies x also is going to be half again. Now, let us take the powers of L this time. It is 3y plus z is equal to 1. Therefore, I can say that directly z is equal to 1 minus 3 by 2. In fact, 1 minus 3y, y is half. So, 1 minus 3 by 2 now becomes minus half. So, the value of z is going to be minus half, x is plus half, y is plus half. What are the values of x, y and z only? Generally they will ask us. So, if that is the case, I have already got all the three values. X is plus half, y also is plus half, and z is equal to minus half. Sometimes they may ask us, what is the relation between these four quantities? How to write the relation? Very simple once again. V is proportional to m to the power half, g to the power half, into r to the power minus half, that I can write it as r power half in the denominator. In other words, I can say V is equal to a constant of proportionality k under root m g by r. This is actual relation between all the four quantities mentioned over there, or you can otherwise call this as the equation giving us the escape velocity from the surface of the earth. But in true sense, escape velocity we have a formula, that is under root 2 gm by r. So, what must be the value of k? You can guess now from that original equation. K must be root 2, but that value of root 2 we never used to get from dimensional methods. So, that is only drawback you can identify directly. Constants of proportionality values cannot be obtained dimensionally or cannot be obtained using dimensional methods or dimensional analysis. That is what you need to remember. So, this is the third use of dimensions, where if you have been asked to calculate the values of powers, you can work out, or you can even write what is the corresponding equation which is relating all the four different physical quantities given in the description of the problem. So, this is the use number 3 what we have as far as dimensions they are concerned.